Buddy. So in this video we're going to finish calculating our distance the missile traveled, rescale that distance, and then calculate the time and initial velocity required to reach the new rescaled distance. So if we recall from the last video, we found a vector to represent the flight path of our missile, which is right here. And we also found the time of impact, which was 1.8572 seconds. Now, in order to calculate our total distance traveled, we'll go ahead and use the x component of our vector, which is right here. And once we substitute in our value for t, we get a distance of 58.0832 feet. Once we've done that, we're asked to rescale the distance so that each foot is equal to 1 mile, which gives us 58.0832 miles. Next, we're asked to calculate the time and initial velocity required to reach this new rescaled distance. So for this, I would highly recommend converting miles back into feet using the conversion formula, which I've done right here. And that gives us a total of 306,679.296 feet. And to save time, I went ahead and wrote out our equation, our distance equation, which is v naught times cosine of t equal to our distance right here. And by using simple algebra, we can divide out cosine theta, giving us a function of v naught of t times t, and that is a total of 424,287.348 feet per second. Another useful equation here is our t equation, and t is equal to 2 times v naught sine theta all over g, which is our gravitational constant, and just as a reminder, g is equal to 32.2. Now we can go ahead and substitute these into our distance equation and solve for our initial velocity and later our time. So I'm going to go ahead and do that now. 306,679.296 is equal to our v naught cosine 43.713, and this is our angle we found using sports motion, times our t equation, 2 v naught sine of the same angle all over 32.2, our gravitational constant. And distributing this, we get 2 v naught squared sine of that angle times cosine of that angle all over 32.2. Dividing out several of these other unwanted numbers, we find that v naught squared is equal to 306,679.296 times 32.2 all over 2 sine of the same angle times cosine of that angle. And taking the square root of this, we find our initial velocity is 3,144.05 feet per second. We can go ahead and put this back into our original equation to solve for t. 306,679.296 equals 3,144.05 times cosine of our angle times t. And simply we use simple algebra to solve for t, and that gives us a value of 134.949 seconds.